is the lesson for Chapter 2, Section 9, titled Percents. And so let's take a look at the first type of problem. It says a set of golf clubs that cost $600. And so this would end up being our whole, where in this textbook they end up using this as the base number right here. And they're on sale for 40% off the regular price. So they're on sale. So we're going to reduce this amount by 40%. And so they want to know what is the sale price. Well, there's a couple ways to do this problem. And basically what we're going to try to do is find a part, and then once we find that part, then we can subtract it from the total. And so we could set it up this way. If you think about it, if I draw a model of what we've got, 100% represents $600. And so this bar represents $600, and it represents the 100% of the item. Well, if I take away 40%, so here's 40%, I can find out what that number is. That would be our part. And so if I did that, I could end up going this way. I could end up saying that we have x over 600 equals the percentage off 40 over 100. And so if I went ahead and cross-multiplied, here's what would happen. I'd multiply the numbers diagonal, so that would be 24, and then 3 zeros, 1, 2, 3, equals, and then I'll cross-multiply this way, I'd end up with 100x. So when I divide by 100, that would give me the amount off. That would give me this part, which is amount off, which would be $240. So x equals $240, but this is just the discount. This is not what they're asking for. See, what they're asking for is the sale price. So I'd have to take that discount and I'd have to subtract it from the total. And so when I go ahead and do that, that would leave me with $360. And so that would be the actual price, the sale price. Now there's another way to do this problem, and it's this. If you, instead of saying, well, let's go ahead and find out what that discount is, we could find out the initial price right off the bat. And so what we could do is, instead of subtracting here, we could subtract percentages. So let's take that same model again. We've got the 100% represents the total of the $600. Well, rather than trying to find out what the discount is, what that part is, we could go a little further. We could say, well, I want to find out what 85% is. And 85%, the way I got that number is I took away, oops, actually it's supposed to be 40. I was thinking of a different problem there, so let me go ahead and erase that part. So I have 40%. If I go ahead and subtract the 100%, or 40% from the 100%, that leaves me with 60%. This is the amount I'm going to pay. This is the amount, or the percentage, I should actually say. So let's go ahead and fix that. So that is the percentage will pay. So let's try to find out what that percentage is. So here is 60%, and we will still want to treat that as a part. And so when I go ahead and solve this, I'll go ahead and set it up this way. I have x, the part, over 600 equals, and then I'll use 60% because that's the amount I'm going to end up paying over 100. And so when I go ahead and cross multiply, I end up with 36 and then 1, 2, 3 zeros, because there's 1, 2, 3 zeros there, equals 100x. So 100x. And then when I divide by 100, you'll see that we end up canceling out those zeros, and I get that same answer, x equals 360. So two ways to think about that problem. I kind of tend to lean towards this method, the second one, because the subtraction was easier. See how these numbers are a little bit bigger. I mean, they're not terribly bad, but it goes a little faster subtracting the percentages because you're just taking a number away from 100. And I'm going to do that same method with this problem here. It's a little bit different, though. It says that the discount store marks up. So instead of going down, we're going to end up adding numbers. Rather than subtracting, we would add. So it marks up merchandise it sells by 55%. The wholesale, so this means like the starting amount. This is like the base, or we can treat it as the whole. So all different words there to represent the same thing. Is $25. What should the retail price end up being? So I'm going to use this method the second method I ended up using, and I'll draw a little model to represent it. So here's 100%, and that cost, the base price of this was $25. Well, I need to mark it up. Mark up means add. I'm going to add on 55%. So I'm going to add on up here another 55% to make this 155%. So I want to find out what that 155% is. And so that's the percent I'm going to end up using. So we've got this. We've got 155% over 100 equals the part. We don't know what that part is, but it's going to be bigger than the whole, because look, my percentage is bigger. So I'm going to multiply these numbers, and this is a good one for the calculator. So I'm going to multiply 155 times by 25. So I'll pull up that calculator. And 25 times 155 equals, and then I get this number, 3875 equals, and this was 100x. The way I got that is by multiplying these two numbers here, equals 100x. So I divide by 100, and what that does is it moves the decimal 2 spaces over. So it goes right smack dab between the 8 and the 7 there. So it's $38.75. So I think that was easier than trying to find 55% of this number and then having to add it to the 25. Either way, you get the same exact answer. So here, another problem that's a discount. It says a used car lot must sell to reduce their inventory by the end of the year. And this year, the sale price is 15% less than the original price, or the regular price. If the regular price is $12,000, what is the sale price? I want to know the sale price again. So I'm going to use that method I used second that I like a little better. I'm going to subtract these percentages, and that's where I'm getting the 85%. I knew there was an 85% in there somewhere. So 85% over 100 equals the part. We don't know what the part is. That's the smaller part. That's the 85%, and it's over 12,000. And so we're going to just go ahead and cross multiply. So another good calculator problem. 85 times by 12,000 equals, and then I have to cross multiply right here, 100x. So I'll pull out that calculator again, and we'll do 12,000 times by 85, and that's going to give me, looks like there's 3 zeros after the 2, so I have, or 4 zeros after the 2, 1,021,000, so it was 1,020,000 equals 100x. Well, that number is going to reduce a bit. When I divide by 100, it'll cancel out 2 of those zeros, which it should. We want the number to be smaller than 12,000. Let's see what the number is. 10,200. And that kind of makes sense. It should be smaller than 12,000. And so that's going to be that value. Let's take a look at another problem. So then we'll also see these problems that involve another formula that we've seen in the past. It's this, simple interest. So whenever we see that word simple interest, this is the formula we're using. I equals PRT. So P stands for principal, and the principal is the starting amount. It's going to be the amount that you deposit if they're talking about putting money into a savings or account, or the amount that you borrow. And so whatever we're starting with, it's the base number that we've talked about in the past, except now we're not going to use a proportion. We're going to use this formula. R represents the rate, and we have to change this to a decimal. So change to a decimal. And then the other one is T. T is in years. It has to be in years. And I don't see, these two problems are already in years. 5 years, 18 years. So they're already in years. But sometimes they'll give you months. And if they were months, then you have to change it to years. Again, I stands for interest. And that's just the amount of money that you make. So that is not the amount of money that you'll have as your balance. That's just the amount of money you'll make. Now, these two problems just ask for the interest. Notice it says, how much interest? How much interest? If they asked for the balance would end up being the interest plus the principal, if it was a savings account. And If it was a loan or something, then you'd take away the interest from the principal. So remember, if they say the word balance, that means you need to combine some terms that you're coming up with. So let's take a look at the problem here. It says you deposit $800, that's going to be your principal, at a simple interest rate that earns 1.5%. This is your rate, and it says after 5 years, that's your time. So you just substitute the numbers in there. So we have 800 multiplied by the decimal form. So the rate is going to be 0.015. So it moves over 2 spaces to the left, 0.015. And then multiply that answer by 5. So let's go ahead and plug those numbers into the calculator. So we have 800 times by 0.015 times by 5. That gives me 60. So I equals $60. They're just asking for the simple interest, and that's what it'd be. If I wanted to find out the balance would end up being the 800 plus the 60. And so that'd be $860 if they asked for that. But in this case, they just wanted the interest. When Marty was born, his parents deposited this much money into the college savings account, earning a simple interest rate of this. Wow, it's a pretty good percentage rate. How much interest will the money have earned after 18 years? So this is our principal, this is our rate, and this is our time. So we're substituting those numbers in there. Interest equals principal, the $5,000, the starting amount, plus the interest, oops, not plus, but multiplied, so let's fix that, multiplied by the interest rate as a decimal, 0.02 or 0.0725 multiplied by the 18 years. So we go ahead and punch those into the calculator. And if we can make that calculator a little bigger, there it is. So we've got 5,000 times by 0.0725 multiplied by 18. And when we do that, we get this number. So this is 6525. 6525. So that's the amount of money that Marty has in interest alone. So this is the amount of interest that he earns. If we wanted to find the total, the balance, how much is in the account, that's when we would add the two together to find out how much he had all together. So looks like he's got 5, 2, 5, and 11, $11,525. Not too bad for that balance. But this is the answer that they were looking for in this case. So those are types of problems you'll see on tonight's homework. Good luck.